Welcome to The Explainer. Today, we're diving into something pretty amazing, a complete guide to mastering AI humanoid robotics. Ever wondered how you actually build a machine that can think and move all by itself? Well, you've come to the right place. So, how do you build a robot that thinks for itself? I mean, really give it a mind of its own. Well, it's not magic, not at all. It's actually a step-by-step journey. And we're about to walk through a roadmap that breaks this whole incredible challenge down piece by piece. We're talking from simple lines of code all the way to a thinking, moving robot. Okay, so the first thing you've got to understand is that this isn't about learning just one thing. Building a humanoid robot is all about layering different skills on top of each other. You've got software, hardware, and AI, and you blend them all together to create something, well, something incredible. Let's see how that's actually structured. And this whole roadmap is really built on three core pillars. You start with the theory, right? You got to know the why behind everything the robot does. Then you get your hands dirty with actual projects. And yeah, you're going to build things, you're probably going to break things. And finally, and this is key, you connect it all to the real world. How can this robot actually solve a problem? Now, this timeline here gives us a fantastic bird's eye view of the whole journey. See how it kicks off? A solid 6 weeks just on AI fundamentals. That's where you build the robot's brain. From there, you move into 8 weeks of robotics basics. That's building the body. And then it just keeps diving deeper. And you'll notice the time commitment starts to ramp up as the ideas get more complex. It's a real progression. And this is a really crucial point. Think about it for a second. Before a robot can even take one step, it has to be able to think. That's why this whole journey starts with code, not with wrenches and wires. We're literally building the mind first before we even get to the body. So this first stage is all about getting a handle on the core ideas that let a machine learn things, process information, and, make its own decisions. Like I said, you're learning how to build the brain from the ground up. So let's peek inside this AI toolkit. First up, machine learning. That's how the robot learns from experience. Kind of like how you'd show it 1,000 pictures of a cat until it knows what a cat is. Deep learning, that's the next level, using these complex brain-like networks for trickier stuff, like figuring out if a person's wave is friendly or a warning. Then you've got computer vision, literally giving the robot a pair of eyes to see and understand the world. And finally, NLP, or natural language processing. Super important because that's how it understands what we're saying and turns our words into actions. All right, so once we've got that AI brain programmed, it's time to move on. Let's look at the next phase, where all that theory and code starts to become a physical robot. This is where it gets really interesting, where the digital meets the physical. Okay, this table lays it all out for us. A great high-level view. You can see exactly how it progresses. You kick things off at the beginner level for 6 weeks, but then you jump into the intermediate and advanced stuff, and the time commitment grows. It's a serious path, for sure, and it really scales up as you get more skilled. And this is where you make that giant leap from just software into the world of hardware. You're not just typing on a keyboard anymore. Now you're learning how the physical robot is actually put together, how its joints are supposed to move, and how to control every single one of its actions. Now, these topics, this is the secret sauce. This is what makes a robot move like a person instead of just a clunky machine. So Robot Kinematics, that's all the heavy-duty math that turns a simple command like grab that cup into the perfect angle for every single joint in the arm. Motion planning is like the robot's built-in GPS. It figures out the best way to get across a room without bumping into everything. Sensor fusion is super cool. It's about blending information from different senses, like vision and balance, to create one clear picture of what's going on. And gait analysis? That's all about cracking the code of walking, which, believe it or not, is one of the hardest things for a robot to master. Okay, sensor integration. Let's talk about the senses. I mean, without them, a robot is basically just a puppet, right? So this whole stage is about plugging in the hardware that lets it see and feel and balance. It's about giving it the raw data it needs to actually understand the world around it. And if you look at this chart, you can see how it breaks down. A huge chunk is LiDAR and depth sensors. That's the same tech self-driving cars use to build a 3D map of their environment. Computer vision gives context to what it's seeing. But check out the other key players here. IMUs, those are inertial measurement units. Think of it as the robot's inner ear. It's absolutely essential for balance. And then you have touch sensors, which are crucial for anything delicate, like, say, picking up an egg without smashing it. Every sensor gives it a different piece of the puzzle. All right, now we're getting to the really advanced stuff. This is the moment where everything, and I mean everything you've learned comes together. You take the AI brain, the physical body, all those sensors, and you merge them to bring your creation to life. We're talking about true autonomy. And to make that autonomy happen, you've got to speak the right languages. You'll get fluent in Python, which is fantastic for getting ideas up and running quickly for high-level control. But you also need to master C++, because when it comes to raw performance, for those real-time systems where every single millisecond counts, C++ is absolutely essential. And this is where things start to feel like they're straight out of science fiction. You'll be using reinforcement learning, which is where the robot literally learns by trial and error, just like we do. You'll program autonomous navigation, so it can map out a room and get around all on its own. And this is so important. You'll tackle AI ethics, really thinking about the real-world consequences of what you're building. And finally, Edge AI, which is all about running those powerful AI models directly on the robot itself, so it doesn't need to be tied to the cloud. And honestly, it's worth just pausing here for a second on that last point. Including AI ethics is so critical. Look, it's one thing to build something smart. It's a whole other challenge to build something responsible. This part of the curriculum makes sure you're asking not just, can we do this? But more importantly, should we do this? So after all that, after the theory, the coding, the building, the entire journey leads up to this one final expert-level challenge. It's time for your very own capstone project. You get 10 weeks. That's it. 10 weeks to go from just an idea to a fully working AI-powered robot. And the thing is, at this point, you're not just following a tutorial anymore. This is about taking every single thing you've learned and pouring it into something that is uniquely yours. But it's not just a free-for-all either. This project actually mirrors the process you'd see in a professional robotics lab. You start with planning everything out, then you collaborate with your team, then comes the really tough part, rigorous testing and deployment. And finally, you document everything so that other people can learn from what you did. It's about learning to build like a real pro. So there you have it. After this incredible journey through AI, through mechanics, through autonomous systems, you're left with this amazing toolkit of skills and the complete freedom to build something new. So the only real question left is, what will you create? What problem are you going to solve? What vision will you be the one to bring to life?